I did this last time I was here, but I'm just going to run through it very quickly. It's a case study for Jamaica, when we did it in 2012 is when we did it, I think. All right. This is a plant, how we designed it years ago. Giovanni from Jamaica, he was here. He will tell you that these chillers are right here. The cooling towers are here. Instead of, this was supposed to be 2 HFOs, initial stages, and this is 4 diesels. Now they have 4, 1.55, 1.5 megawatts, Jamaica natural gas. At that time, Jamaica didn't have natural gas. So we were looking at options. And the options we looked at that time was diesel, HFO, and they had LPG. So we were thinking initially of going HFO. We didn't. In fact, this is now is going to be the 1.5 megawatt Jamaica. But phase 1 involved using the chillers, 2 exhaust chillers, direct fire and exhaust, multi-energy chillers. So they can run on LPG or diesel or waste or exhaust. These are the exhaust ducts from the generators going into them. So, right? And there's a hot water chiller because the hot water from the generators, the radiators, can be piped to this hot water chiller. So it's 2 800-ton absorption multi-energy, direct fired or exhaust, and 1 800-ton hot water chiller here. And these are the cooling towers. And the plan is going on now. Phase 2 is being done right now. And Giovanni was in Jamaica last week and looking at it. I was there. For the last 4 years, they've been running on phase 1. Just these 2 chillers running on LPG, right? So what was the best solution for Jamaica? In those times, you just can't buy a generator and go for tender and go and buy whatever absorption chiller you want. You want to get the best. You want to know what is the best solution for me. So you have to do engineering analysis. And those who went to engineering school will know we did something called linear programming, right? In year 2 or year 3, right? So that's what we did here for Jamaica. So this is the load profile. So during the night, they'll down to like 2 megawatts, and in the daytime up to 6 megawatts. And this is the profile during the week. On the weekend, it was like this. So you have to look at the load profile, analyze what you need, okay? And then the cost of HFO at that time was $15.55 per MMBTU. LPG was $22.80, and diesel was $28.38. Now LNG, we put our next line here, is about, I think they get it from Fortress for about $12 to $14 per MMBTU. Okay? Everybody negotiates. That's one thing you have to negotiate. So UWI was probably the biggest customer, so they negotiate a very good price. Okay? And then the generator exhaust. This is something you need to know as well. If you run a generator on HFO, the exhaust temperature will be about 350 degrees Celsius, but that exhaust will only give you 35 tons per megawatt hour. Okay? If you run on LPG, you get 480 degrees Celsius, you only get 292 tons per megawatt hour. If you run it on diesel, you get the highest exhaust temperature, 540, and you get more tons. Okay? So what is the best solution for Jamaica? For this particular customer, UWI, right? So that's what we do. So we look at determine the least cost solution for UWI. You look at the fuel cost, the cost of LPG is cheaper than diesel. Now the cost of LNG is even cheaper. That's why they switched to LNG. Okay? The operator maintenance cost. We assumed both diesel and HFO was the same. Capital cost, the LPG generators are more expensive than diesel. The ability to provide cooling from waste heat. Diesel generators have exhaust at 550 and can provide 442 tons per hour, while LPG generator exhaust is 480 and provide 292 tons per hour. The environment. Diesel is harsher to the environment than LPG, and of course we know LNG is even the best. Okay, and that's why they're using LNG right now. Air conditioning constraints. The university needs 2,531 tons of cooling between 7 a.m. to 7 p.m. when the school is open, and 300 tons from 7 p.m. to 7 a.m. at the night. So they have a need for power, and they have a need for cooling. Okay, so the power constraints were the UWI needs 96 megawatt hours between 7 a.m. and 7 p.m. 8 megawatts at 12 hours, 7 a.m. to 7 p.m. And that's what they wanted. This is the future, because right now we saw before they were using 6. But they said we're going to expand it. It's a basic medical complex. They opened and increased it to 2 megawatts. So that's why they need 8 megawatts. So when you have all this information, you do the linear programming like we did in school, Excel spreadsheet, seek to determine the best mix of plan to minimize cost to UWI. Model development, develop the decision variables, determine the objective, the constraints. Decision variables will be how many megawatt hours should be produced using LPG, we call that LPG. How many megawatt hours should be produced using diesel, we call that D for diesel. Okay? There's a mistake here. This should be LPG here, and this should be diesel here, because the capital cost of the LPG costs more than diesel, the generator. The maintenance cost we put at the same, and the fuel cost, 55.62 was the cost for LPG, because it's cheaper than the cost of per megawatt hour than the cost for diesel. So basically LPG is 343 US per megawatt hour, and diesel would be 305. Okay. So the assumptions: capital costs, term years, maintenance, operating costs of both generators are the same, but really and truly you can work it out and find out what it is. Fuel costs at current rate and no escalation in costs. Normally you need to put an escalation there. And the objective function, you want to minimize the overall cost to the university. So you want to minimize 343.49 times diesel, all right, times 305. This should be the other way around, because this is LPG, and this should be diesel here. Yeah, I mixed it up, okay? And then the power demand, diesel plus LPG is 96 megawatt hours. That's what they want in a 12-hour day, right? Cooling demand, 422, that's the tons, times diesel, plus 292 tons for LPG is less than 30,392 ton hours for 12-hour day, okay? And then the nitrogen oxide, you know, the pollution, you have to watch the pollution. So they have, I think Jamaica had some laws in terms of the pollution. They want 2 times diesel plus 0.47 times LPG is less than 298.6 pounds NOx per 12-hour day, okay? And when you put that into the equation, simple spreadsheet, Excel could do this thing for you, okay? Sorry? Yeah, you get, we get this here. I think this is a switch because we had more diesel. In fact, our recommendation was for more diesel than LPG. The LPG was base loading. So this is a switch here. This is the LPG here, diesel. It meets the 96 megawatt hours. And when you add the cooling load, because again, free cooling, the total cost of the CCHP plant was 30,050 versus if it was usually local utility, they'll have an electric cost and a cooling cost of 48. So we're saving 18,000 per megawatt hour per year. And that's why they decided to go. I had to sell this project, and that's why I had to sell it. I'm the one who sold Jamaica. I'm the one who sold all these projects. You have to go on, and it's hard. It's hard to sell people these things because it's not like selling an air handling unit or a chiller. You have to prove it works, okay? And up to now, the UWI has not. So Giovanni, I hope you really get this thing started because the UWI needs to see that it works. They have been running it on LNG for the last couple of years. They didn't have enough money to go to the phase 2. Okay, so that's why they're doing phase 2 now, and they're moving forward with it, right? And then the sensitivity analysis. You need to look at the sensitivity analysis. If the cooling load constraints drop below 28,000 ton hours, then all the power should be provided by LPG generators. Likewise, if the cooling load increases above 40,000, then all the power should be by diesel, because diesel gives you more cooling than LPG, right? So those are the things you have to learn. And you know what we found out? The information they gave us initially was incorrect. They said they're going to go up to the tonnage of 2,500 tons, is it? Yeah. No, they overestimate the cooling required. So a simple thing of not doing your homework and doing your energy or your energy, your heat load calculations properly, they overestimate the cooling, right? And that could affect your end result. So you have to have proper engineering analysis, okay? And I don't think they even need 6 megawatts. How much, Giovanni, they put in 1.5 megawatts? 5, right? 1 is backup? No. Okay.
You need to have one backup.
Or you need to have one backup. But I'm not even sure. What is it? Are they still at 6 megawatt or are they at 8 megawatts now?
They are at 6.5.
6.5.
Yeah.
Okay, and they're running full.
Megawatt to play with, but
okay.
still need to run.
Right? So you understand? You have to do a proper engineering analysis. You have to analyze the loads. What is a proper cooling load? And you know, some engineers like to, we don't want to get embarrassed and it's not cooling. So we overestimate, or we put extra. Instead of 10 or 15%, we might put 20%, right? I don't know about Puerto Rico. I can't speak about Puerto Rico, but in Trinidad, sometimes the engineers raise it high because they get like 5% of the cost of the services. So they get more money. I've seen 2 or 3 big projects where they overestimated the size, right? Because they didn't do proper heat loads or whatever else, right? And to get better, more, 5% of the cost of the project, get more. I'm not saying it does here, but I've seen it happen before. So you have to have your numbers properly to get a proper sensitivity, to get a proper end result for the project, for the customer, okay? So and the other one, if the power demand constraint drop below 70 megawatt hours, then all power should be provided by diesel, blah, 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 blah. This highlights how very important it is to have a proper analysis of both the facility power, demand profile, and the cooling load profile when selecting for CCHP projects. You have to do your analysis. That's clear. It's clear, all right? The strengths of the model, good initial determination of what plan should be selected, is replicable, expandable. Sensitivity report provide good insight into alternative available should singular changes in contract happen. And look at risk analysis. We could do things like that, Weaknesses, risk. Quantitative model does not evaluate qualitative risk. Fuel supply risk, product quality risk, right? Selecting different suppliers for both generators and chillers, right? Modeling various load profiles. UWI model on steady state load of 8 megawatts for over 12 hours should model vary daily load profiles, availability of competence technical staff. You don't have competent technical, and they didn't have, you did not have competent technical staff. They had problems with the children plant. We maintained it for 2 years, and then they took it over, and they didn't do it properly. So you could do all the risks, all the models you want, and it looks nice on paper. You don't do proper maintenance, you're not going to get what you want, right? So this is a serious business. A lot of money, you have to do it right, okay? Limitations, ideal profitability. If we wanted to minimize UV costs and similarly maximize ideal profit, 2 objective functions, right? We used a software called Tora, and the information available was the limitations.